So in this problem, what we're having is a 2 by 2 matrix, and we're going to have this matrix as A. So what we have to do is supposed to find the inverse of this matrix using elementary row transformation. So to do that, remember that when an identity matrix is multiplied with your matrix, you're just going to have the matrix itself. So let's just substitute the values of A and I. And remember that when you what you have to do in this problem is basically you're going to make the A on the LHS, which is the 2 by 2 matrix, into a identity matrix. Okay, so once you make the matrix on the LHS into an identity matrix, automatically your identity matrix on your RHS is going to become your inverse matrix. So what's going to happen now is we're going to first do R2 is equal to R2 minus 3 times R1. So the point of doing this is we're going to get 1 and 1 in the second row on your LHS, and on your RHS you're going to have minus 3 and 1. Remember that when you're applying the operations to the matrix, you're supposed to always apply for both the LHS and for your RHS. So now what we're going to do is you're going to try and get 1 in your first position. So to get that, what you're going to do is you're going to have R1 is equal to R1 minus R2. So once you've done that, you're going to have 1 0 on the first row and 1 and 1 in the second row. So it's very easy now. All you have to do is you're going to make your third element into a 0. So to do that, what you're going to do is you're going to have R2 is equal to R2 minus of R1. So once you've done that, you're going to have 1 and 0 and 0 and 1 on your LHS, which is an identity matrix. Since you have an identity matrix on your LHS, you're obviously going to have your inverse matrix on your RHS. So your RHS, which is your inverse matrix, is going to be 4 and minus 1 on the first row and minus 7 and 1 in the second row. So that's your answer.